Hello everyone. Today we are going to study a very basic topic, sensitivity. So, sensitivity is defined as a quantitative measure of amount of change in output of the system due to change in input or a system parameter. It is a very basic definition, as sensitivity can also be defined as if you are driving a bicycle and you are driving it fast and you have put a brake, which is a power brake, and just as you have put the brake, the cycle stopped. This means the sensitivity is very high. And if the brake are very old, the sensitivity becomes low. You have put the brake, but the sensitivity becomes low as enough that after putting brake after 10 seconds, the bicycle stops. So this defines the sensitivity. So sensitivity in control system is defined as ST by K, where del T upon del K by K is the sensitivity formula. So sensitivity is del T by K. We can write it like this as well, del T upon del K into K upon T, where T is the function and K is the parameter. Therefore, for a simple network, first we calculate the sensitivity. Here the transfer function is T1 equals to G, and the sensitivity can be taken only at the one parameter, which is a G here. So sensitivity over G equals to del G by G upon del G by G, which is equals to 1, as both parameters are same. So for a control system, for a simple parameter, we can write the sensitivity as 1. Whereas if we take about the feedback, for the feedback network, R, we can say as the input, C as the output. The C by R here comes out as G upon 1 plus GH. This is a very basic. We all know this. The transfer function come out as G upon 1 plus GH. And the sensitivity parameter, here are two sensitivity parameter. First parameter is the gain and the second parameter is the feedback. So first we talk about the gain, then we talk about the feedback. So for the gain, del T2 upon T2 upon del G by G equals 1 upon 1 plus GH. We can derive it as well. For derivation, for the derivation, we can say the sensitivity parameter del 2 T2 by G. So del T2 by G will put all these things. Del 2 T2 upon G will comes as 1 upon 1 plus GH. So this is the sensitivity of forward gain with the if feedback. If we talk about the positive feedback, only the sign changes. 1 upon 1 minus GH. So we can say negative feedback, the sensitivity decreases, and in the positive feedback, the sensitivity increases. Now we talk about the sensitivity parameter with respect to the feedback element. So feedback elements del T2 upon H, derive it as well. I am not deriving it. It will come out as GH upon 1 plus GH for negative feedback and GH upon 1 minus GH for positive feedback. So this is the sensitivity that comes out for both values. So this comes out as the feed sensitivity due to feedback element. So sensitivity due to feedback element is negative for the negative feedback, and sensitivity of the feedback element is positive due to positive feedback. So negative feedback, if we talk about the next point, the negative feedback decreases both gain and sensitivity, hence increases stability. Whereas positive feedback increases both gain and sensitivity, hence decreases the stability. So this is the benefit of the negative feedback. Only negative thing of the negative feedback is that a drawback, which can be said as the gain decreases in the negative feedback. So now we talk about the next point is the feedback element. The feedback element must be more sensitive than the forward element because of the stability of the system. So the sensitivity of the closed loop system with respect to the forward path element should be low and the feedback path element should be high. Here we talk about the parameters, we have to talk about the T, we have to talk about the K. What are the key takeaways from this? So negative feedback, it decreases both gain and sensitivity, hence increases the stability. Positive feedbacks, on the other hand, increases both gain and sensitivity, hence decreases the stability. In closed loop system, forward path elements sensitivity should be low, and forward path element sensitivity should be high. So the feedback path must have high sensitivity and the forward path element must have the low sensitivity for stability in a closed loop system. So to increase the stability, there is a way: decrease the forward path sensitivity and increase the feedback path sensitivity. Let's take a question of the sensitivity and understand it in a simple way. So now we solve this question. This question is a very simple question about the sensitivity, and the all of the topics majorly cover this question, which comes in most of the university exams and the competition exams as well. So in this question, the forward path element is given like this and the feedback path element is given like this. So we calculate the transfer function, which comes out as g upon 1 plus gh, which will be 10. And the sensitivity, so in this question, we have to calculate the sensitivity of the closed loop sensitivity if the forward path element sensitivity is 10%. So if the forward path element the sensitivity is 10%, we can write it as del T by T by del G upon G equals to 1 plus 1 upon 1 plus G. So this is given as 10%, and we have to calculate this. We will multiply it there, 10 upon 1 plus 9, which will be equal to 1%. So my transfer function is 1% sensitive. This is the negative feedback we have taken here. If nothing is mentioned, we will consider it as at negative feedback. The default feedback is the negative feedback. So now we talk about the closed loop sensitivity if the feedback element is 10% sensitive. So the feedback sensitivity is minus gh upon 1 plus gh, and the del t by t upon del h by h. So the feedback path element is sensitivity is this. This is given it as the 10%. Now we will calculate is minus 10 into, this is given it as 100 into 9 by 100 upon 1 plus 9 by 100 into 100. So this will come it as 10. A closed loop sensitivity if the feedback element is 10% sensitive is the 9%. So this shows a second observation that the feedback element should be more sensitive for this system to be more stable. So this is very simple example. Here we how transfer function is sensitive about the forward path gain and how transfer function is sensitive about the feedback path gain. Hope you all understand. Thank you.